Hey, welcome to another live stream at Developers Garage. I'm your host Ryan Overton, and today we've got a few things in store for us. So, like always, this stream is about making ourselves more productive, getting better at what we do, our craft of software development. And so, one of the things I want to make sure I highlight on these streams is some of the little tips and tricks that I've found that can make you a better developer. And we'll say good morning to the chat room out there. If you're watching, thank you. If you're watching in the future, thank you for taking your time to listen and watch me as we go through these. All right. As you can see down here, I've still got my lighting issues with my green screen. The awesome thing is I have a solution to that problem. Our good friend Sharp Fritz, he took some time and basically gave us a nice list of everything he does when he does his stream. He has a very professional stream, and it's very enjoyable to watch. And so he actually turned me on to some lighting that he's using, and you know what? It makes sense. So I've been trying to use standard lights here and there that I find in around the house, and I can never get it to work quite right. As you can see, I've still got some issues here. It's either the screen's too bright, it's too dark, there's shadows, all that kind of stuff. But he had a real simple solution. He's using a couple of little LED lights, 15-watt lights, that are multicolor. And so what he's doing on his stream, on his green screen, he's projecting the color green. I never thought of that. My mind was blown when I heard that. I was like, it's such a simple solution. And hopefully you find that solution a benefit as well. I'm going to switch on over to our coding screen here. We'll talk a little bit about what we've got going on today. Let's transition on over. So here you can see I've got Jeff's blog pulled up here. If you want to find out what he's got set up, how he's got everything set up, head on over there. Check out his live stream at Sharp Fritz on Twitch TV, or go on over to YouTube to the Sharp Fritz channel and check out some of his previous videos. He's doing some awesome stuff with the Elgato Stream Deck. He's built widgets and tools for streamers like me. And he's also just building some cool stuff. He was kind of my inspiration for getting started on this. I'm kind of a budget streamer to an extent, though I do have the nice microphone and everything, but I'm running on, this whole stream is actually being run from a Surface Book with a performance base. Very nice, very productive. What I ran into last time on the stream, if you watched it, you'll notice there were some dropped frames. So rather than being able to just upgrade my machine to more power, I had to go ahead and just use what I had. So the issue I was running into is when I was trying to do some of the development tasks, such as npm install last time, or what we're going to be doing today with actually compiling some code and running some unit tests, it started to slow the machine down. And when the machine CPU gets high, frames started dropping, video started freezing, the sound kept going, but you were not able to actually see me or see what's going on the screen. So he had a great idea early on in his stream. When he first started, was he actually remote desktop into another PC, and that's what you can see here on screen right now. What I've got going over my shoulder here is I'm remote desktop into another machine, and this machine here allows me to run my code in a separate environment, effectively sandbox on another machine, but still stream it live to my channel and on the recording so you can watch. So that's another little trip. If you're beginning, you are a developer, you want to get started, but you don't have a large budget, then make do with what you got. Find your way around these things. Like I said, I'm using another machine here to do all my development. As I get better at this, and maybe throughout the year, if I get some money saved up, I will get a much better machine. Jeff has all his stuff lined out here. The mic he's using, the mixer, so he's actually using a professional microphone with the XLR connection, which is standard for the audio industry, into a mixer, which allows him to control a bunch of little different things from his mixing board. Rather than having, like myself, I have to use the tools built into OBS, or Streamlabs OBS is what I'm using, or into Windows itself to control it. So I love the fact that he's posted all this. He actually has an old version of his blog where you can see where he started and some of his ideas, and that's where I got him. Down here, he talks about how he's got his settings set up, the camera he's using. I'm using actually a Logitech C920 or a 920. It works great. The monitor provides enough light, so I don't need the little camera ring, and it lets me see everything that's going on. Or, let's see what's going on. It actually lets you see me, and my monitor provides enough light. These are the little lights, $30 on Amazon. I actually got them on a lightning deal for $25. Like I said, they're going to put green. They're going to project green onto the green screen, which is going to give it, hopefully, that nice deep green and help prevent shadows. Here's his computing power, which, man, 4 cores, 8 logical processors, 32 gig of RAM. I wish. Most I've got is 16. I can't remember if my Surface Book's running 16 or 8. He's got an awesome video card in it that he upgraded. Basically allows him to render the stream much better. You see he's got talks about all the displays. I've got, if you don't count my remote desktop machine, I've got about 3 displays. One's running OBS, the other's running the main screen here, which you can see where it's being projected, where we'll do all our development. And then I got another one here that's got a couple little admin tools on it, as well as Chatty, which allows me to monitor my chat room. Welcome, chat room. Welcome to those of you who've just joined or have been watching for a few. And here is his keyboard he's using. He's got a lot of different things. Here's the awesome thing, which it's on my bucket list to get. It's like one of the things, the next thing I will probably get is the Elgato Stream Deck. So right now, whenever I change scenes, go back and forth between like being full screen or back to our other screen, I have to go into my OBS studio. I don't have hotkeys set up. I would forget them if I did. So, but the Elgato Stream Deck allows you to basically pre-program all these. So it's like hotkeys with buttons and symbols, which are easy to use. You can have them right at your fingertips. Easily change the scenes, add audio, sound effects. I do have sound effects, but they're in another scene right now. So probably won't use those today. And then he goes on and talks more about the software and all that. Being able to add, people in through Skype. This might tax my machine a little bit, but I may give it a shot to see how it works. Have some people on, some friends, some tech experts who can help me along my way as we start the development process. If you want to see Jeff's streams, go to @Sharp Fritz or go to his blog. You can see when he's streaming. He's doing about 3 days a week right now, I think. He'll actually be bumping that up to 5 days a week if I'm not mistaken. I know he does it on weekends, and he's actually going to be doing an evening stream for those of you who are in other places other than the U.S. My stream, I'm going to try and keep it during my lunch hour, which is 12. I may bump it early or later depending on the day, but I'm going to try to keep it the same day, same channel, same time. Easier for you to remember, easier for me to remember, and just get in the habit of doing it. All right. So I talked about tips and tricks earlier. I have made a few notes of things that I wanted to talk about here on stream. First thing is I'm installing, Visual Studio 2019. Actually, I did install it pretty quick, actually. So one of the things I myself love doing is I like playing with the latest and greatest code. I like playing with the latest and greatest tools. I like to see what's coming. Production-wise, a lot of employers are a little frown against it. One of the awesome things about Visual Studio 2019 is the ability to run both versions side by side without affecting the other. So as you can see here, I'm running Visual Studio 2019. It installed all while I had, well, that's 2019. Where is my, there she is. My 2017 instance here. So as you can see, I do have an update. I was thinking about updating, but if you're getting ready to go do a presentation or a stream, don't update. That's a big tip. Don't update right before a presentation or a stream. You never know how long it's going to take, and you never know what it's going to do to your machine. You may have to reboot. You may have other things that happen. It could take 15 minutes or it could take an hour. So, developer tip, wait till the end of the day to do it. Or if you need a break in the morning or at lunchtime, run it over lunch. So let's go back to 2019. As you can see, it's got a brand new, this is the start window. So this is our start. So I can do anything. I can clone or check out code, open a project solution, open a local folder, or create a new project. Or we can just continue without code. And so one of the nice things I like about it, they got rid of the space up here. They're using as much available space because when you're developing, you want to see as much code as possible. You don't like to have to scroll. I don't. So let's compare it to what 2017 looks like real quick. Oh, hotkeys don't fail me now. There we go. So you can see we got all this extra space up here. Maybe I can open them side by side here. Oh, what do we got going on here? Come on. There's that. Let's look at them side by side. You can see all the stuff that they've done to try and maximize the amount of space they've got. Start menu's changed just a little bit. You saw the old start there before. File new. Everything that you're familiar with is there. It's actually just pushed up a little bit. They got rid of the title. We know what the program is. We know what we're doing here. We know why we're here. So why not move the file, all this context menu up? You still got the same great search. Live share. As you can see, it is telling you it's a preview. So this is 2019. It is not slated for production use. And I would not recommend using it in production yet. For all my demos and everything I do, I'm going to be using 2019. It actually runs very fast. Some of the Xamarin tooling, which I'm a Xamarin guy, like Xamarin Forms, and it just compiles your code at 50% faster. Now, when you get in there and run it, it may still feel slow, but just imagine doubling that time and how long you would have to wait for it to compile and move it over to your device and run it. So 2019's got some great things going on in it. Live share. One of the other things I want to talk about is live share. If you've never seen this or never used it, I think with 2017, it might be an extra plugin or a download you have to do to install it. But the beauty part is, if I wanted to share code with you before, or if we wanted to pair a program together, what would we have to do? Typically, either we've got to do a remote desktop session where you can see my screen, and so somebody's watching, sitting there, looking at the stuff, looking what you look at, and watching you type code. What Visual Studio Live Share gives you the ability to do is to actually bring in that solution and project into your version of Visual Studio. Whether that's Visual Studio on Windows, Visual Studio on Mac, or even VS Code. So you could even be on Linux. And you're able to see the same solution, the same project. You can even actually see where I am in the code and what I'm doing. The other beauty part is if I give you access or the other person gives you access, you can actually make changes in the code. So it takes programming to the next level. It means you actually don't have to be sitting physically together. You can be worlds apart and still pair program together. So one of the other things, and let's bring up 2019 here. So one of the other things that I thought I would show you guys, just as a little tip, you may know this. We're going to create a new project here. We're going to just do a simple console application. Console app 1. Let's place this someplace else. So let's make a, go to my PC here, C drive. I have a dev folder. Let's see what the dev folder contains. It contains some snippets. That's fine. That's where we're going to place it. We're going to place it in our dev folder here. Console app 1. To choose your version of the .NET framework. You know what? I don't want to do a framework app. Let's go back. I want to do a core app. .NET Core, the future of everything. Oh, what? Let's try that again. All right. iOS, Android. Now the question is, when I did this, did I actually create to where I can do .NET Core applications or not? Console applications. I only have, All right, let's take a look at this real quick. We'll do these tips and we'll get back to this because I really want to get Core going. I want to make sure we use .NET Core. A lot of advantages to Core. It's lighter. I can run multiple versions of .NET Core side by side, whereas previous .NET framework, you had to basically pick which framework you wanted to run on your machine. It got installed on your machine, and that's what everything used. So if I wanted to test out new features in the latest version of the .NET framework, guess what? I'd have to install it. And then that framework is now on my device. That framework is actually the main framework of the device. Now I can target older frameworks, but it's not quite the same because you still have that one. You still have basically a new installation. So when we get started talking about some DevOps talking, if you have to recompile your code, it's a new set of bits every time. So if every stage that I move my application, my pipeline, I have to recompile, those are all untested bits. There could be new things in it. There could be changes in it that I don't want in certain environments. Whatever code we test in dev, whatever code we test in QA should be the same bits that move on over to production. So that's the beauty of .NET Core. I can have multiple instances, multiple versions of .NET Core installed side by side. So I can test and play with the latest bleeding edge versions to see if I like what's coming. Just prepare for when it gets here, I'm ready to use it in production. So today, we're just going to use the framework here real quick. .NET Framework 4.6.1. It's building my applications. I see some people showing up in the chat room. Thanks for showing up. Hopefully you all can hear me. I've not seen any chats come through yet. So if you can't hear me or can't see what I'm doing, or if the screen's too small, and you know what, that actually makes sense. So let's bump this up a little bit to make sure everybody can read. So if the font or anything is a little too small for you, just let me know, chat room, and we'll bump that up for you. Let's see here. Let's reload. All right. So, you ever do type stuff like var temp equals new, let's say, string. You get that light bulb over there. Oh, there she is. I see a lot of people doing this. I see a lot of people always go over here. They'll take their mouse, they'll come over here and click it. Remove the unused variable. One of the cool things I like to do is I like to take a little short hotkey. It's ingrained in my mind because now every time I know I'm going to need to do that or bring something in, rather than having to go do a using statement, I hit control dot. The control dot, control period. What that does, that activates that context menu. And then I can do everything from the keyboard. I don't have to take my hands off the keyboard. It's a few little extra motions I don't have to do. It's going to speed me up. I can remove that unused variable. And so that's a little tip. Let's see, I had a couple here, more here. So one of the things I learned just the other day by basically following people on Twitter is, all right, let's create a new class here. Most people use interfaces. Most people will implement an interface when they're creating a new class. There's some things about interfaces that are kind of, when you implement that interface through the helper commands, it's kind of annoying what it does. So let's go ahead and let's add a new class here real quick. We're actually going to create this and make this an interface. We're going to call it I thing because naming is the hardest thing to do in software development. I don't care who you are or what you say. The things I have that give me night sweats, wake me up the most, derail me the fastest, is trying to think of a name for something. So we're not going to spend time thinking about that. And again, certain things just bother me. Ooh, do that. All right, so we have a property. We're going to have a string thing one. We're going to have maybe a method here that returns a string. Call it thing method. So I like to always capitalize my public properties. Use, I think it's called Pascal casing. I always get the terms on the casing. It's not, I don't think it's camel casing. I think it's Pascal casing. Chat room, if you know the answer to that, please just shout it out. And we'll make sure everybody does. Checking some things here on the stream, making sure everything's looking right. Frame rate looks good. All right. All right, so it's telling me something's wrong here. It doesn't like something here. So we want to use a property. So we're going to use a property. It is, you know what? I'm going to get rid of this. I don't like that. For some reason, I've never been used to putting properties in my interface, though I'm pretty sure you can. So, all right, let's create another class. We're going to call this class thing, you know, because we have iThing. We have an interface for a thing. Let's just create a new thing. Public. All right, but we want to implement our iThing interface. Lit up for me. Because they're in the same class, because they're in the same folder, I don't have to add any kind of new usings. They're in the same namespace. But it's telling me right here I haven't implemented it. So we can use that little trick we learned earlier. It's called implement interface. So you can implement the interface. And there we go. We fixed it. So the one thing I've always been frustrated by is why do you set it up as throw new exception? Throw new not implemented exception. Because then I have to go clear that out on everything I don't want to do. So one of the cool tips I learned is you can actually change the behavior of that. If you haven't seen it before. Let's see. It's an environment. It's in, I think it's the text editor. C#, because I am a C# developer. All the way down at the bottom here. Implement interface or abstract class. When generating properties, I guess I do need to add a property there. You want to prefer auto properties. If you had a property there before, it would have implemented them with null, or not implemented exceptions. And so with this little change, I don't think it will affect this. Come on, 2019. Realize I have not. There we go. Implement the interface. So it still throws not implemented exceptions here. So let's go back to iThing real quick. Let's add a new property. So the other thing I've learned is some little snippet commands. So prop, it's typically a basic one included inside Visual Studio. Allows you to quickly and easily implement a property. So we're going to call this the thing property. What are you oh, because we're in an interface, it can't be public. There we go. All right. So now we've done that, let's come back over to our thing and let's take a look at it. So we have iThing. So there, it's realized that I've added a new method, or a new property in this case, and it's saying, hey, you haven't implemented this. Let's implement it for you. Well, that didn't work like I wanted. That's the beauty of live programming. You get to see everything that I don't know and every mistake that I make. But you know what? Everyone does it. Everyone goes through it. And so we're all going to learn together. Let's see if I just do this. It's gonna complain. You know, I'm gonna go to our good friend Google. You know, he or she, it always helps me out. So C# interface property. Interface properties. Hey, here we go. Pretty simple. Let's go back to that, because that may have actually done exactly what I wanted it to do. Let's go back to the blog post real quick. Okay. All right, hop on back to code. I'm gonna actually go undo the thing I did before here. Prefer throwing properties. All right, so let's come back over here. We're gonna go ahead and get rid of all of this. And we're gonna come over to iThing. We're gonna re-implement it. So there you can see. All right, so this is the thing. If you have a property in your interface, what's gonna happen is and it looks like I'm starting to freeze and everything. So I have to monitor what I'm doing that's causing that. It may be this Twitch dashboard here. Let's go ahead and let's close that one down. I may have to open that up on a third computer. If I can scrounge one up. I have a few lying around that are a little outdated, but you know, just viewing a web page like Twitch probably work just fine. But you can see here, when we have it set to throw on properties, it's going to sit here and put in here all these new not implemented exceptions. It's kind of annoying because why doesn't it take advantage of the auto property? That was where the tools options here came in play. So when you start out, you just go to text editor, C#, advanced, scroll all the way to the bottom. And when generating properties, prefer auto properties. And so now, when we undo that, let's come up here. Things that make us more productive, because we implement auto properties. Hey, it's a little tip. Hopefully you get some use out of it if you didn't know about it. I didn't. It was something that's kind of mind-blowing. And I think it's going to make me more productive, because that's less code I have to remove at that point. So one of the other things is every now and then I have to go through and I will implement we'll use this one as an example. We'll create a new property here. So use my prop snippet, inserts everything. I just have to give it the type now. We call list of string. I can hit tab, which will move to the next field that I actually have to do something with. And then we can name this another thing property. And it actually keeps bouncing back and forth. If I keep hitting the tab key, it'll keep going back and forth between the two values that the snippet needs me to fill in. And once I have it down, I can just hit enter and it accepts everything. Whoa, bump my mic. Now, if you hit enter after you do the first one, guess what? You're going to have to go highlight the name and change it if you want to. Little gotchas there. So I have that public. I typically like to have backing variables for a lot of things. Some things, models and stuff, I'll just use auto properties. But when I actually have a view model or something, I'm going to have some kind of logic built into it. I like to have backing properties for a lot of or backing variables for a lot of my properties. So here we're going to create there may be a snippet for a private property. I don't know. Chat room, if you do know, please shout it out so everybody else can see. Everybody else will know. And then we're going to call this another thing property. And we're going to make this a read-only property. The nice thing sometimes about these, if you didn't know, if you remove the setter and just implement a getter, you have a read-only property. Yes, a read-only public property. You're not going to be able to set that backing property. So we're just going to do return another thing property. So some of you out there may be screaming at me, you don't have an underscore there. Guess what? I don't like underscores. I don't know why it bothers me. It's something as a developer that I don't like. Now, as part of a developer, a part of a team, and a part of a community, if the team says, hey, we're using this pattern, you're going to preface all your private variables with an underscore, then I would follow that. There is no I in team. I am not a dictator of a team. You should not be a dictator in a team. If the team thinks that underscores are better, then we use underscores. Why have people typically wanted to put underscores there? It's when you are in methods like this, and I think it's IntelliSense kicks in. So when I start typing, when it starts looking at things in here, I start typing A, or I bring up this menu. I have a lot of stuff in here. A lot of people liked the underscore for the simple fact of, so the other thing, the control dot here to basically rename it. I know ReSharper, if you are a ReSharper person, there are some hotkeys for ReSharper that allows you to just go in and rename it. There are other ways to rename a property. You can right-click rename, and it'll rename everything there. I like doing it first and then telling it, hey, go fix everything. Again, that's just the way I work. But if I type underscore, that moves it to the top of the list. That's moved it. That's typically why that I heard that people use the underscore. A lot of the work that the Visual Studio team has done has gone around to making the IntelliSense smarter to try and determine what you're going to do. And so in my mind, that has negated the reason for the underscore. A lot of people still like it. Nothing wrong with that. I just prefer this. So another thing, property. So usually when I have a list, sometimes when I'm quickly getting things going, I want to basically get things built up fast. I'm going to use dummy data. And so we're actually going to make this a list of things. Oh, when I change that back, I forgot to. Oh, let's go. There we go. Change this type to thing. You're going to complain because you need a thing there. I'm going to get rid of that because we don't need that. And we're just going to return nothing just to make the Visual Studio happy. So one of the other things is I have to new up a new thing, set some kind of property. This is another thing, property equals something. That's because it's a thing. Yeah, we're not going to do that. Just imagine though, this is a property I would have to implement, and then to get dummy data in quickly, what I would do is I typically would hit go from the front to the back, highlight it all, Control C, do my little comma, Control V, Control V, Control V. So that's kind of a lot of stuff to do. Plus it also copies that to my clipboard, but I can use Control E, V, and it copies the line that I'm currently on. Just some little tips and tricks that, you might not know that might make your life a little bit easier if you started doing things, started using them. By no means feel like I'm saying you have to use them, because I'm not. All right. So those are the kind of little tips and tricks that I've got. There's a couple things more we'll talk about later, a few other streams, but I want to get to what our stream is about today. So what are we talking about? So today's stream is about code katas, unit testing, and bowling. You're like, what do all three of those have in common? So if you've not heard of a code kata, let me pull it up real quick here, or heard of a kata in general, what is a kata? A kata is, as I know it, as I understand it, is a martial arts. It's a martial arts. Let's see, what's the best way to describe it? Not form, but it's a martial arts routine. It's basically a set of movements that you practice over and over again. And the idea is that as you do them and practice them over and over again, your muscles creating memory. And so what it's starting to do is meaning you don't really have to think about what movements I need to do to perform these set of movements. I'm not a martial arts person. I don't really know anything about it other than watching some Bruce Lee or Jet Li movies. That's about the extent. I know I've had some friends who have taken it. I've got a good friend at my current employer that he used to own his own studio. And so he understood kind of the purpose of a kata. So there are a lot of different ones out there. And so when we talk about code katas, let's go with that real quick. A code kata is kind of the same thing, but we're not trying to get your physical muscles to learn, or your physical muscles trained. We're trying to get your mental muscle trained. And so when we do a code kata, we're practicing not necessarily something that's difficult to think about. It's more of the logic or the way we're going to implement something. And today's, we're going to do unit testing. And so the idea is that unit testing is something a lot of developers find hard to do. They really have trouble finding a lot of value in unit testing. In my opinion, you're going to feel that way when you start doing it. I believe you have to find that aha moment where unit testing makes sense. So, let me break it down for you a little bit here. So my aha moment, it's probably been about 4 years, maybe 5 years now, back when I had my aha moment. I was working with a business analyst / architect. I don't know what his title was at the time. He had written a mesh-style framework for a WPF desktop application. And he built his own timers and a whole bunch of other different things that could be used across all these different components. So the idea was you could write these different components and effectively create a menu system that could be used inside a store. So I worked at Quick Trip, a convenience store chain at the time. If you're from the Midwest, Phoenix area, Atlanta, Dallas, Texas area, you know what Quick Trip is. So working there, I got to develop the menu system used on what we call the back bar PCs, or the PCs that were run behind the counters. And so the new menu system had the ability to take existing programs, or you could write a specific new functionality that could just be dropped in, and when the system rebooted, it uses reflection, went out, inspected the DLLs, and just all of a sudden it appeared. And it was usable. One of the things that the analyst architect wrote was a timer. He wrote some complex logic about when this timer would run or what would happen. It was very configurable. You could have it happen at the beginning of the day, when the PC restarted, every hour, every 30 minutes, every other hour, on Monday, Wednesday, Friday, Saturday, or whatever day of the week you wanted. It was very complex, and it had a good set of unit tests that made sure that the functionality worked. My job was to implement a new timer function. I don't remember specifically what it was, but I wrote the code, and like every developer, my code was awesome. My code was the best. It worked flawlessly the first time I wrote it. I was happy. I did one smart thing that day. I ran the unit test before I checked in the code. When I ran the unit test, 7 out of 14 of those had failed. Now, because of the way this system ran, it was very hard to manually QA. And so, most likely where these issues would have been caught would have been out in production. So, I would have had about, I don't know how much stuff not working. And to try and debug and figure out the symptoms that affected that would have been, in my mind, almost impossible. Because as we all know, your users never give you the exact steps that they do. So that was my aha moment. I had wrote the code. Mine worked. The problem was I broke functionality for 7 other types of timers. Oh, I thought I had quieted all that. Let's go turn you off, Yammer. Do I have anything else in here I need to turn off? Everything else looks like it's okay. All right. So that was my unit testing. That right there showed me that I needed to, unit testing was valuable. That saved me a lot of time and a lot of heartache because I would have been the one that had to figure out what happened, what was wrong. And so, am I a proponent of TDD, test-driven development, where you write all your unit tests first? I would say, yeah, I'm a proponent for it, but do I actually do it? No. Like most people, I write my unit tests after the fact. Again, but that's where this code kata comes in. So this code kata is called the bowling game. So that's where the bowling comes in. No, we're not going to be writing a bowling game, but we're going to be writing effectively a bowling engine, which basically is going to calculate the score of a game. And so it's going to have a couple of different things in it, but we're going to start with unit tests first to try and instill that idea that you need to write writing your unit tests first and having them fail and then writing the code to make them pass, what the benefit can provide to you on that. As well as show you that when you refactor, you can ensure that you have not broken any other functionality throughout that. Because if you've had to do any kind of legacy maintenance before, which I've done way more than I ever wanted to do, you'll know that it's very scary to refactor some of that code. Because taking a procedure or a method that is 500 lines long and breaking that apart, but still, you can write the code and you believe everything works, but you never know when they've done something just to handle one specific little use case. So, all right. Let's go ahead and kick that off. So, talked earlier, we're doing the Bowling Kata, written by our friend Uncle Bob. So if you're not familiar with Uncle Bob, look him up. He's got a lot of good stuff out there. One thing I would recommend for reading, if you are a reader, it's one of the things that helped me and changed my life. Clean Code. It's a book. You can get it on Amazon. You can get it on your Kindle. I think I got it on Kindle, and that's where I read it. It kind of changed my mind. It kind of helped me kickstart my development career. And I say career because when I started developing, I just wanted to code. That was my idea of a career. So what I did was I said, you know what, I want to be better. I knew there were better ways to do things, but I didn't know how. And so I started reading. Clean Code was one of the things that I found. And there is a second version called Cleaner Code. Ooh, plus there. Cleaner Code plus. I swear that was the name of the book. Start with Clean Code. It's old, but it's language agnostic. It's more the principles and the logic behind what you're doing and how you set up your code. And so in my mind, it's so far it stood the test of time. You can see it's originally published in 2008. And this is by Mr. Martin here. So now that that's out of the way, let's get started. And we'll start doing our code kata here. So, no, I don't want to save changes. So as you can see over here in my stream, I've added a new widget. So just like with everything, I like the agile process. So with every stream, I try to look and see what do I need to do better. One of the things was, hey, we'd like to be able to see the chat room. So, hey, chat room. And so in a second here, we're going to see that show up, as you can see up here. So that's a little widget I've added, something I noticed we needed. The benefit of that is as I take these recordings and I upload them to YouTube, you will be able to see what the chat room is saying. Pardon me, a little dry throat there. Talking a lot can do that to you. Wow, has it been 50 minutes now? I got to stop talking so much. All right. So the other thing is you see this new little widget down here, this agenda widget. So this is something that Mr. Fritz, Jeff Fritz, had originally built for his stream not quite a year ago. It's a little widget. Basically, it allows me to see if you come into the stream in the middle or at the end, you can actually kind of figure out where we are instead of jumping in and saying, hey, what's going on? Or, hey, where are you at? Or so it's kind of a way that you don't have to, you can just come in and see what's going on. Please feel free to still ask what's going on and what we're doing, but this way you'll kind of have an idea of where we are, what we're going to next, and where we're going to end up. So the agenda right there that you see right there, all the way over on the other side, is basically all the things we're going to implement. So I did say earlier I wanted to use .NET Core. So the one thing I didn't see in here was a .NET Core template. Why didn't I? .NET Standard, .NET Framework. I got a .NET Standard library, but I don't have a .NET Core. I could go on and we could use .NET Standard. That'll allow me to basically say I'm going to write it, and I want it to be able to move it across. So I could have it, and I could put it into my another .NET Core application. But I do want to get .NET Core going here, so we're going to go ahead and stop that. We're going to close this out. So that's the one thing, the benefit of live coding. You get to see all the stuff I do to get things running. So we're going to start our trusty Visual Studio installer. Woo, there it goes. Visual Studio Enterprise. We're going to modify this. So one thing to know about Visual Studio is they have this idea of workloads, which makes it easier to say, hey, this is what I want to do, and then it's going to go install all the things you have to do. Instead of going out to the web, going to Google, going to Microsoft Docs, and trying to figure out what all do I need to install in order to be able to do desktop applications or .NET applications. So I chose .NET Desktop Development when I did this, when I probably should have chosen .NET Cross-Platform Development. There we go. That's why it was missing. Oh, wow. So it's going to do that. So one of the things I do have, though, in my other, so we may use 2017 today just so we can get this going, because I do have .NET Core. And if you don't know where to get .NET Core or how to get it, it's not something you go into your Windows settings, add or remove programs kind of thing. Go to .NET. I like to search Google. Basically go to .NET Core here. That probably wasn't what I wanted to do. Oh, there we go. Tells you right there. Download the SDK. So you want to just download the .NET Core SDK. What we got here is we have .NET Core 2.2. Let's see what I actually have on this machine. So, whoa. Developer command prompt for VS 2017. Did you know that's her? As an old school developer, I'd say I'm old school. I'm getting old. I turned 40 this year. Not looking forward to it. Let my hair grow out a little bit over Christmas break. I started seeing some gray hairs. I don't like that. It sucks getting old. Come on, don't fail me now here. You know, I had a little trouble with my command prompts last time. Not sure what's going on here. Come on. You can do it. I know you can. Okay. The other thing, you want to download Visual Studio 2019 Preview, check out the new stuff. Do what I do. Go to Google, search Visual Studio 2019, hit go, and then pick it from the list. That's going to take you to visualstudio.microsoft.com/vs/preview and just download it. You could probably just bring up your Visual Studio installer, though I think you have to have a previous or an updated version of the installer for that. So just hit download preview. and it gets going. It was actually pretty quick. Obviously, when it's doing .NET Core, it's going to take it just a little bit longer. Did my command prompt open? Still nothing. Oh, there we go. I think I have a screen refresh issue here, as it was sitting there. So, cd dot cd slash. I forget my DOS commands sometimes. You know, you bounce between PowerShell and Linux and DOS, or the command prompt. You forget how things work. You start typing the wrong commands into the wrong window. So, I do have .NET installed, but the question is, which one do I have installed here? Probably not the latest and greatest, though I could be wrong. Here you can see my core runtimes. Looks like I got 2.1 is the latest one. I got the preview, 2.1.6 preview, but we also have the 2.1502. So, and I believe .NET Core, let's see, that's the support policy. I think, yes, .NET Core 2.1 is an LTS. It's a long-term support release, which means it's going to be out there for a while. So it's one you can count on to be supported for a little while, rather than, you know, next week they come out with .NET Core 2.2.1 and you're like, I have to upgrade again. I don't want to do that. Nope. They have the idea that they're going to do a long-term support branch. I don't know what the policy specifically is on that. So let's see. Does it tell us? 3 years after initial release and 1 year after a subsequent LTS release. So after 3 years, they may do a new LTS, or if they create a new LTS, I'm not sure what that means. It seems kind of a little double-sided there. It could mean, hey, if we could release something we call an LTS, we could say, hey, that old one, that one's not going to be supported. Or it could mean they're supporting 2 LTS branches. I don't know. But you're at least guaranteed, most likely for 3 years, you're going to have support for your branch. So if you do a new .NET Core application, you have about 3 years probably, if you start the beginning, until it's updated. But they made things so if you keep things updated as you just maintain them, you'll save yourself that hurt. Now, obviously, if they don't have the functionality you want or need, you don't want to do that. Certainly understandable. Oh, it's downloaded. It's finishing up. Come on, .NET. So, cool thing is I may actually have a new version of .NET installed. Of course, it may not be there just yet. Oh, the other nice thing, I think I mentioned it before, I'll mention it again. If you install 2019 and you have Visual Studio 2017 open, you don't have to restart. It's not going to make you shut this down to install the updates to 2019. It'll make you shut down your other 2019 instances, but it won't stop you in your 2017 branch. So that's the nice thing. All right. So it says that's there. All right, let's check it out here. Let's create a new project. Let's see if we have our .NET Core installed now. Look at that. There it is, a new .NET Core class library. Awesome. Console app. First thing in the list. It knows what I want to do. That's what I like. I don't like to have to think. Because if I start thinking, we're in trouble. For all of you who don't know, I've got an Ozarka water bottle here. Just water and Crystal Light. I don't have anything fancy. I don't drink coffee typically after 12, so let's get started. Finally, with probably some of you, if you're watching, the reason you're here. I'll try not to be so long-winded in the future streams, but let's go change our branch here. C:/dev. And we're going to call this the Bowling Game Kata. Oh, hey, it wants... Oh, that's right. New folder. There we go. All right. I'm going to call this the bowling game. And so it's going to create me a new console application. Any minute now. Bueller. There we go. All right. So, because this is for unit testing, we do need a unit testing project. So we're going to go add a new project here. And we're going to go to test. So one of the cool things is you got a couple different test types. MS test, NUnit, XUnit, or the .NET Frameworks unit test project. We're going to go with, I think XUnit is what I want. You know, this is probably something I should have looked up in advance. One of them has a different syntax, one that I'm not entirely familiar with. Let's just see what it says. My first unit test, so it uses fact. NUnit may be what I want. Basically, I want to just call it a test class. So NUnit. Yeah. Show me how to do it. NUnit. Unit testing C# and NUnit with .NET Core. There we go. Let's see. Create your test project. Yeah. Where is it? Is this what I want? Test fixture, test case. Or do I want MS test? Let's see what MS test looks like. MS test may be what I'm used to using. Yep, there it is. Test class, test method. All right, we're going to do an MS test for .NET Core. Always .NET Core. Let's everybody say it together now. .NET Core. I want to use .NET Core. Okay. Now that we've got that down, we're going to call this the Bowling Game Test. Yeah. Bowling Game Test. All right. And whoa. Yeah, I don't want to do that. Visual Studio. No. Actually, yes, you want me to do that, don't you? Hopefully you didn't see that. I have to watch to make sure, but I'm pretty sure you didn't. All right. You want me to sign in? I signed in. Use this account instead. All right. Don't make me do it again. Please don't. All right. We're going to call this Game Test. It's gonna be smart. Generate overrides. Rename type to game test. Another thing. Love these things. Control dot. Always. All right. So, as you can see here on our agenda, we have all the different tests we're going to end up writing for our kata. So we're going to start with a gutter game. Now, if you've never bowled before, you're not used to bowling. How bowling works. I'm going to see if I can't hold this. Oh, there we go. Bowling has a set of frames. I know if you're looking at me, you're like, I don't really know what that says or what that means. Bowling has 10 frames. Each frame you can bowl twice, or you have 2 chances to get all pins down. If you get all 10 pins down in one roll, it's called a strike. Hopefully you know what bowling is. You don't have to have bowled before, just have to understand the concepts. So, we're going to call this the gutter game test. And here in just a second, I'm going to show you another cool feature I like about Visual Studio 2019. And I think it's also available in 2017, though it works much better in 2019. So, gutter game test. So how do we test a gutter game? So, we need to roll. We have to roll X number of times. So first thing we knew is we need a new game. So let's come over here to our bowling game and let's create a new class here. Actually, no, we're going to do it in here. So the idea is you want to write your test first and have it fail. So var G. I prefer the var syntax to explicitly typing. Some people don't. My preference is using the var because Visual Studio and Roslyn and the compiler, they're very good at determining what type you need. Very rarely do I not use var, and if I do, that's only because I set the initial value to null, where the compiler has no way to tell what type it's going to be. So, and it won't let you do it if you set it to null anyways. So var G equals new game. Tries to be too smart sometimes. New game. I know that's not right. I know it's not going to work. That's fine. That's the first thing we've got to overcome. So we write our test is where I need a new game. I don't have a game. Let's go create a game. So go over to our bowling game project. We're going to create a new class called game. Make it public. I don't get. I've been developing for 12 years now almost, and one thing that always frustrates me is that every time I create a new class, it's never public. I don't understand it. I don't get it. If somebody out in the chat room or somebody in watching this in the future can tell me why we don't automatically create a new game with a public preface on it, public attribute, please tell me. Please help me out here because I want to understand. Every class I create, I have to go put public in front of there. All the developers I've met, I'm not alone in this. So I'm curious at what the thought process was behind not putting that in there. So, all right. So we got a new game. Come back over to our test. Still not working. So we can use our fancy control dot here to bring down the context menu. I can rename game test to game. No, I don't want to do that. Or I can add reference to a project. So this was one of the other things that you have to go say, all right, I'm going to explicitly add my project in there, and then IntelliSense will pick up, okay, you added this reference. Now I know about the game type. And I'll add the correct using. Now it's smart enough to say I'm going to add a reference. So that's awesome. So it actually added the reference to my project and then added the using statement up there. So, and I could actually run this test and it would run. It's going to compile. Build succeeded. Test passed. Why did it pass? Because we didn't test anything. It's the easiest way to do a test. So never write a unit test like that. I've heard of developers gaming the system where you can just do a simple assert dot equals 1 and 1. What the gaming here does is that it says, hey, I've tested the methods. They're inside my test, and the unit test passed. Wow. Whoa. What happened? We broke Visual Studio. Well, that's what you get when you play with experimental preview features. Sometimes they don't work, and sometimes they crash. Cool thing is, hey, it came back. Came back where I was, got everything there. Save. Save often. Repeat after me. I will save often. Control S. Quickly save. A lot of developers have been burned a lot by writing a whole bunch of code and just assuming that the system's going to save, and when it crashes, you lose however many hours of work. Personally, I build often because when I build in Visual Studio, it saves it. Now, Visual Studio Code is a little bit different. It does not save your open files whenever you build from Visual Studio Code. At least not that I found. So Control S, save and save often. All right, so let's build again. Build succeeded. Let's go to our unit test runner. Let's run this test. Yes, build succeeded. There we go. All right. Oh, it did. It did not save everything. See, that's why it didn't. I didn't save the assert statement I was writing. Assert.r equal 1 and 1. That passes. So watch. I can run this unit test. Guess what? It'll pass every time. Run it again. 8 milliseconds to run that time. One test passed. Because 1 always equals 1. That's okay. So we're writing a gutter game test back on track. I get sidetracked a lot. If you need me to move on, move quicker, say, hey, get going. And I'll move along. I may get going on tangents. So the thing we need here, we need to be able to test. So we do want to assert dot r equal, and we're going to say the expected output is 0, because in a gutter game, basically you've gone down those side alleys and you don't get any pins down both times. So a gutter game is you never knock a pin down in all 10 frames. And then we're going to say g dot total. All right, so a couple things here. This is going to fail because we need a total property. Come over here, back here, my handy little prop. And I think this will work as well now. So I forgot to set my prop. Call it total. So nice thing, we can actually do a default property now for auto properties. This kind of does a little bit away with the private backing if you just want to set the initial value of your auto property. If you want to be able to manipulate it behind the scenes and do some other things, you're still going to need a backing variable for that. But for this instance, this works perfectly for us. So now let's build this. So we can run this. And look, it's equal. But hey, wait a second. You didn't actually write any code that actually rolls or does any of that. You're right. So what we've done here is just test at the beginning of the game that it is 0. But you're right. We have to do rolls. So what do we need to do now is we need to actually roll a gutter game, hold 10 frames. So with each frame, you get 2 chances to knock down pins. So that means with each frame, we have to roll. With each frame, we're going to roll basically 0. We're going to knock down 0 pins. And so what we want to do is we want to basically do a little for loop here. For int is equal to 0. While, forget how you use for each loops for so long, you forget the syntax a little bit of a for loop. I is less than, so we need to do 2 for each frame. 10 frames, it's 20. So while I is less than 20, and we need to roll 0. So again, I plus plus. Now my for loop's right, but I'm missing the roll method. All right, so go back to your game. Again, this is test-driven development. So what we're doing is writing our tests and see it fail or where the issues are, and then we're going to go fix them. The idea is that we now know that we have a failing test, and if we fix it and it works and it passes, we know we're good. So we need a new method here. So I can do, that's for test methods. We're just going to go ahead and do a public void roll. And we want to take in the rolled value. Let's call it rolled. There we go. So I just wrote my method now. Again, I can run this test. And it passes. So the idea, and I know you, I can hear you saying it. I can hear you screaming it. You did not roll anything, Ryan. you're right. We didn't store it anywhere. That's okay. We'll get to that. We'll get to there. We have a passing unit test. We're good. So, on our little list down here, we have a gutter game. Our gutter game test is good. Except for the fact that it should be 20. So, all right. So, the next thing we've got going on here is live unit testing. If you've not heard of live unit testing, it's something that was introduced last year. I believe it was 2018. But it's the ability that instead of having to explicitly right-click on the method and run tests, or the class to run all the tests, I can have it do it for every time I make a code change. Every time I save, it's going to try and run the tests. And so what we can do is we can turn on, from here, live unit testing. We can start. So what that's going to do is basically it's going to start monitoring and start running. So now if it's getting started here. Okay. So you can see here, this is what you get when you start doing live unit testing. So if I do 1. Oh, I said earlier I had to save. I don't. I just have to change the code. So this could get annoying as if you're typing and writing code, trying to think logic out. It might get annoying. But it saves me from having to actually rerun the test. It's going to tell me real quickly, what do I have that's not working? So I do 0. Reruns. It passes real quick. All right. Next one. Test method. Public void. We're going to test all ones. All right. All ones. It means for every roll we do, we knock down 1 pin. Okay? So, we need a new game. Again, this is not about, these katas are not about how we write the code. It's getting our mindset, I said write the code, how we, basically the syntax we use, that kind of stuff, how we structure the code. It's more about how we think when we write the code. We get in the mind, we're training our brains that I need to write the unit test first. We're getting our mind, the logic going that I'm going to write the test first and then I'm going to write the code. And that's what this is instilling. Like again, this is not to teach you how to write unit tests, although it can help a little bit. It's to get you in the mindset of writing unit tests. So, and so we're just going to copy this because it's about all the same code, except we're going to change our assert and we're going to change our roll. So we're going to roll 1 and we're going to expect the total to be 20, right? So we have 20 times we roll, and for every time we roll, we're going to roll a 1, which is going to be for 10 frames. All right. So look at that. Tells us our unit test failed. So now we get to go fix what we already know is broken. The other thing, and it just popped into my mind, the other thing TDD is helping you with is you don't write any more code than you actually need to accomplish the task. A lot of developers get caught up in the fact that they start jumping out that high level view and start saying, I'm going to need this piece, I'm going to need this piece. In terms of bowling, okay, I'm going to need a lane, I'm going to need a gutter, I'm going to need a screen, I'm going to have to display everything on there. And they just get so caught up, it's really hard to focus on the task and get the task accomplished. What this is also teaching you is just only write the amount of code you need to complete the task you're working on. The task I'm working on right now is we're rolling 1 pin every time. That's all we're doing. We're only going to write the code that's going to make sure that that test passes. No more, no less. So now we're rolling. Now we need to add up things. So let's go back here. All right. So like before we said, all right, we need to store what we roll. So we do need an array here. So we need an int array. We'll call it roles equals new int 20. I think that syntax is correct. Do I need these? Do I need parens after this? No, I don't. I think that works. Okay, that looks right. And so we also need to track of, since we're in an array, we're going to be storing things when we roll. We need to keep track of what roll number this is. So we need another. We're going to make this a private int. Actually, I just screwed up. Only write the amount of code it's going to take to basically accomplish your task. So total plus equals rolled. It's that simple. I was writing more code than I needed to write. Look at that, my test pass. That tells me that everything is good. Again, I know. Switching to just plain water now. I know. You're like, it's not right. That's fine. We did accomplish our task. So if we had a task list, which we have over there, make sure I point the right way, over there, then this is what we've got to do. Knowing that when we're done, we will have a finished product. Got to keep in mind, the task is there to accomplish one thing and one thing only. Single responsibility principle. Do one thing and do it well. Your goal as a developer is to complete your task, not design the entire system. That's done at a different stage, a different step. When we're developing, we're focused on just completing our tasks. We want to make sure the code we're writing is maintainable, written in a good way, but our goal isn't to come up with a system design while we're coding it. We do that, like I said, we do that in a different step. So, test one spare. So what does that mean when we test one spare? Oh, hitting things and moving on. All right. So test one spare. Where are we at? All right. We tested all ones. Got our game test. We need to write. Oh. Anybody else notice something? Anybody else knows what I did before? So I copy and pasted. One of the big no-nos in development. There's some debate about that. I've seen some things out there in the Twitterverse that are debunking that to an extent, but typically if you copy and paste, you have an opportunity to refactor. Now, if that refactoring involves in greater complexity than the existing system, you're going to have to roll the dice on that. You're going to have to basically weigh that cost benefit analysis. So it may be better. You're like, you know what? I get more benefit about a refactoring, or you know what? It's just cheaper to just copy and paste. There will be a time though that technical debt you're building will exceed your benefit, and you'll be like, why didn't I refactor? So just remember that when you're doing this. All right, so let's do one thing here. So for our test, we need a game, right? So, and we're just going to call it lowercase game. All right, and then we can replace this with game equals new game. And that way, for every test, we get a new instance of our game. Or the other thing we can do a basically a, what is that called? A test initialize class. I think it's public void. And we're just going to call it init. So what this does is that what it's going to do is that before every test, it's going to run this method to basically set up our scenario for us, or set up our default data, depending on how you want to do your test. Basically, just remember that at this test initialize, it's going to run before every test. So we're just going to say game equals new game. And so what I've done here, again, that cost benefit analysis, I don't need that extra step there. So we save. And what is our live testing saying here? Covered by one test, covered by one test. Let's do a build. G does not exist. Well, look at that. So it's called game now, right? Okay, so we'll change that to game. Game. One of the bad parts about being red-green colorblind is sometimes it's hard to see the little squiggles under there, telling me that I have something wrong. But those check marks did tell me that, and so that's where we research. That's where we dive in when we don't see something that looks right. All right, so there you go. It's working. Now, if you know that your class is not going to need to be reset if it's a stateless class, a stateless system, and you're like, you know what, I only need to new it up once, they have another method you can do. It's called a test class initialize, I believe. And we'll look at that one real quick. All right, actually maybe class initialize. All right, class initialize method. So the thing about this method is it's run once for every class. And so we need public void class init. And it's not French, we're English, so it is void. Public void class init. So our class init, something doesn't seem right still. I have all these errors. No, they just have not cleared out from the previous time. Again, using preview software, you may get some unexpected things. That's the price. So what's wrong here? There's actually something. If I build. All right, 0 errors. 2 tests failed though. Why did it fail? So let's look at it. So it tried to init the class. The class init has the wrong signature. The method must be static and public and does not return a value. All right, so class initializes our static methods, which means whatever they work with has to be a static as well. Because I cannot say game equals, yeah. Because this is an instance-based variable or property, I don't have access to it in a static class. Most of you probably know that if you've been developing for a while. If you're new, you just learned something new. So this has to actually be game equals new game. I can take that one away. And let's rebuild real quick. Method must be static, public, and does not return a value, and should take a single parameter of type test context. Read the whole error message. The test context. This class should be fully abstract and not contain any members. So All right, there we go. And now we have it where it basically only initializes every time we once for the entire test run versus for every test that we write in newing up a new instance of the game. Other methods you might want to know about, there is test cleanup and class cleanup. So if you do modify a database or some external third-party product, you may want to go clean up what you've done. That's what the test cleanup and class cleanup are. We don't need to do that here. Or if you need to basically, if you are outside of managed code, outside of the framework or core, and you're actually dealing with memory space, allocating and deallocating, you want to then go make sure you deallocate that memory. So, all right. Hang on a second. I have a new puppy back there, and I just want to make sure she is not chewing a hole in my rug or on anything that could hurt her or make my wife upset when she finds out that it got chewed up. All right, so we talked about that. Moving on down, we're going to go to our all ones test. So we still have some duplicated code here, so we can actually refactor that a little bit. One of the other things you can do is we can extract a method from this. So we're going to extract a method here. We're going to call it roll. Gives those things, apply. Why did it make it static? I don't know. I don't want it to be static because it's only gonna it's not gonna happen. I don't want it to be able to be run outside of the instance of the class because I need to have something set up before it runs. So, excuse me. Where are we at? Roll. All right. So the other thing that we want to make sure this roll does, we want to take, the value we're going to roll. So we pass rolled. And here we need to tell it what value. And there, we just did our first refactoring. As you can see, I know that my unit test still passed with this refactored. So that's the other benefit we get with unit testing. We can do some extractions kind of like this and still are assured that what we do, everything is still going to work as it needs to. So we can come down here. We can update this down here and we can say we're going to roll 1. And there we go. Everything still passes. Everything's still running. I'm going to have to pause for just 1 second. I will be right back. All right, I'm back. My apologies for that. Told you about that new puppy I have? Yeah, she was chewing on something she didn't need to be chewing on. Trash, nothing I was really too concerned about, but I want to make sure she understands her boundaries up front. So, enough with puppy. There she goes. She's actually crawling back under my desk. She hides. So, all right, so here we go. We've done a little bit of refactoring. I want to actually move this. So other little tip, if you want to take a whole section of code and you just want to move it up, make sure you get the right amount of code. But All right. You get a section of code you want to move up. You want to move it into a new area. Highlight it. And you can use the Alt key to move that section of code up. Move it around. To get it right where you want it. Organized how you want it. This works for me. And so we're going to move on. Just Alt and the up arrow or down arrow key will take your selection and move it up or down. You can highlight everything. Actually, I just have to be on just have to be on that same line, and I can move it up or down. Fun little tips. Again, some of these things I forget until I need them. So we'll be doing some of this as we move on. All right. So moving on to our next test. One spare. So there is a nice little snippet for this. Test M for test method. Puts that test method attribute there and allows me to just change it. So we're going to test one spare. So a spare. What is a spare? A spare is when you actually within a frame, and on the first roll you knock down, say, 6 pins, and the next roll you knock down the other 4 pins. So in your 2 rolls for that frame, you knock down all 10 pins. So what we want to do is we want to test what happens with that. So what happens with that in scoring is you get the score for that frame. So each frame is the sum of both rolls. In a spare, it's the sum of both rolls, which would be 10, plus the total of the next roll. Does that make sense? So if frame 1, I get all 10 pins down in 2 rolls. The next frame, I get 2 pins down in that first roll. That means for that first frame, I get a score of 12. It's 10 plus the first roll of the next frame, 12. So what do we want to do is we want to, first thing we do is we want to roll a spare. So roll 5. Easiest way to do it's, in my mind, it's just to roll 2 5s, 10 pins. So that's a spare. And then we need to do our, again, look at that. I didn't understand the method I was doing. So we need to do game dot roll a 5. Game dot roll 5. So there, my first frame, I rolled a 10. So for the next set of rolls, I just want to roll, I want to roll 0. I want to roll 1s. Actually, here's the way to do it. Okay, roll 2. So we get the scenario we just talked about, to get a 12. And actually the total is going to be 14 because you get 12 for the first frame, and then if we roll 0s every other one, basically you're going to get 14 out of that. So assert are equal. We expect to have 14, and our game game dot total. Oh no. All right. That's what we expected. I knew that was going to happen. So there are a couple things that we're going to do here to fix this up. All right. So the first thing is, in order to calculate the total of a frame, we actually have to know what the previous rolls were. So, or the next roll. So in a spare, I have to know what is the next roll and what its value is in order to calculate the total of that first game. So earlier you saw me try to implement an array here to store all the totals. That's what we're ready to do. We actually need to store and actually know the values of each roll. So what do I want to call it? Private. Call it rolls. Need an array. We know we're going to have a total of 20 rolls. So I need 20 spaces in my array. New. Need the new. All right. So the nice thing is, even inside this game, it's telling me that, hey, this method has failing tests. So I can click on here. It's covered by 3 tests, one of which is failing. So instead of adding every time we roll and adding it to the total, we're going to take that out. So we're going to say rolls. Now we have to know what roll we're currently on. So we need a new variable. Current roll is what we're going to call it. We're going to start at 0. Unlike Visual Basic, which I say that, I don't know if they've changed it now or not, but previously Visual Basic was a 1-based indexing on its arrays. Not .NET, but C# is 0-based indexing. So we're in C#, we're using 0-based indexing. Whatever language, this can actually translate to whatever language you're doing. Just be aware of what your language's array indexing is based off of, 1 or 0. So we're going to do current roll equals rolled. So what we're doing here is, for whatever roll we're on, whatever they say they rolled, we store it in that array. Now the game keeps track of what frame you're on or what roll you're on. That's how we want it. So the other thing we haven't done here is we need to make sure we implement the current roll value. Now the other thing we can do here, we can simplify this. If you're familiar with the ++ pre and post. So what this does here is saying, hey, I want to increment current roll by 1. So this is equivalent to current roll equals current roll plus 1. Now, there are 2 ways to do it. You can do it like that, current roll ++, or you can do ++ current roll. Now, they mean something different. So this is, if you've not used these or not quite sure of exactly what that means, you're going to learn something. If you do, if you're watching this in the future, skip ahead a few seconds, just skip this part, or just ignore it. So ++ before the variable, the ++ operator, before means before I dereference this value, and I hope I'm using the terminology correctly. Before I dereference this value, I want to increment it by 1. So basically, if I was to do this, get rid of that for now. What it's going to say is before I get that value and basically get into this array at whatever value's in here, I'm going to increment it by 1. And so it's post-processing, maybe the terminology for it. Not quite. It's a little shaky on that one. Again, chat room, if you know this, please shout it out. But what we're going to do is we're going to increment it by 1 before we use it with inside to get whatever array position we're in. Now what that would do is say, instead of going to 0 position, we're going to go to the 1 position, which we don't want. But we do want it to increment. So when it happens after the variable, it means it's going to get the value, use it, and then once that call is over, it's then going to increment the value by 1. So this would actually work. It saves us a line of code. Determine what your team's comfortability with that is. If they want it on 2 lines, it's not that big of a deal. But this is a perfectly valid and acceptable way of writing this. All right, so we're going to move on. So our tests are still failing. So let's come back over here to the test real quick. So we are storing our rolls now, but now all our ones test is failing and our test 1 spare. That's because our total is no longer calculating it. So I'm going to add a new method here. It's going to return an int, and it's going to basically calculate total. Now the other way to do this is you could make this a method here, and then pass that back. Is that what I want to do here? Sometimes these are the hardest things to figure out. But no, we're going to do it like this. All right, so we're going to calculate the total. I know what I'm going to do. There we go. All right. And we're basically going to go for I equals 0. Well, I is less than roles.length. Why am I not using 20 in there? If you're asking or wondering that, that's because if I change the value of 20, or I change the length of that array, I'd have to remember to go do it in other places as well. This is going to say no matter what length I change it to, this is just going to work. So, and we're going to say total plus equals roles I. All right. And then we're actually, we don't need, yes. Total score, let's call this score. 0. We're going to say score plus equals roles. And we're going to return score here. What I'm doing is just letting this calculate total method calculate the total of the game. Okay? Not using it anywhere, but what we're going to do is we're going to say, okay, we're actually going to make this kind of a read-only property here. Return calculate total. So now what's going to happen is every time this game, only auto element properties can have initializers. You can't make it read-only and have initializer. So we're going to leave this set there. Just for the purposes of this. Since it's not a total auto property, it's saying, hey, I can't set it like this before. So, that's what I can do. It's going to be happy with that. Looks good. All right, why do we have an X here? Let's come back to our test to see what we have that's failing. So I have my role. So it's saying I'm failing, covered by one test. System.index out of range. Index was outside the bounds of the array. Interesting. I initialize it. We roll. Current roll plus plus. All right, let's check this out. All right, let me try this here. Take this down by 19. Let's just see if we're somehow Still saying it's failing. You know what? Let's debug the test. Put our breakpoint in here. It's the benefit of live coding. You get to see and we get to figure out why things aren't working together. Debug the test. Looks like I have a little bit of freezing going on. Not sure what's causing all that, but my apologies if the stream does freeze on us. All right, so let's. Oh, they changed my step out, step over commands. Let's step into roll. I less than 20, I plus plus, game.roll. All right, so roll, our current roll is 0. Aha. So I actually do know what the problem is here. And it's actually not the code we've written. It's actually how we initialize the game. So I put it in the class in it saying, hey, the program is stateless. Game is stateless. That's not true anymore. Game actually is keeping track of what role we're currently on. So after it runs the first test, it's going to go through and then say, okay, let me run through all this. It's going to run through 20. So our current role is going to be, at the end of this test, is going to be 21. The moment I try to run the next test, it's going to go in there and it's going to say, it's going to try to put whatever comes into rolled into what the current roll is, and that's going to be 21. And that's why we're getting the index outside the index. Index outside the bounds of the array. All right. Nice. Glad we got that figured out pretty quick. I'm just going to move this down to here. And this should actually solve our problem. Hopefully. We'll just rebuild real quick, make it run all the tests over again. So this one down here should still fail, as it does, because this should actually be 20. I changed it just for a test. Boom, there we go. Still running. So still have an issue here. So what's the issue? Index was outside the bounds of the array. Now, I know why this is. So what we're doing is here, we're rolling 3 times, and then I'm saying, okay, I want to roll zeros. The problem is my roll method is going to roll 20 times, which again is going to go outside the bounds of the array. So we need to change our roll method a little bit here. We need to tell it, we need to find out how many times do we need to roll. So we're going to call that roll times. We're going to take that to here. All right, so now I got to go fix all my roll methods. So I want you to roll 20 times. I want you to roll 20 times. I want you to roll, since we've already rolled 3, I only need you to roll 17 more times. All right, so there we go. We're failing, which is good. But we're failing not this time because of an exception. This time because we failed because we expected 14 and we got 12. So now we know we need to go fix the game test. I hope you're seeing the value of unit testing as we go through this. Maybe you have your aha moment, or you've had it. Maybe you look at this and you're like, you know what? I see the value in it. So we've got to actually make it calculate a spare now. So let's see, what are we going to, so how do we calculate a spare? So we have to basically go rolls current roll plus plus. So we have to know if, so we have to know is spare. How can we do that? No, nope, I don't want to do it there. That's the roll method. I want it in my calculation method. So what we need to know is if score dot, if rolls I plus rolls I plus 1 equals 10, we have a spare, right? Excuse me. Let's do little comments here. We have a spare. Else, no spare. No spare. And this is just to help me think as I'm going through this. All right. Neck's bothering me a little bit. Getting tight. Wow, my longest stream ever, 2 hours. I should have known that this was going to take a little bit longer, but if you are watching bearing with me. Thank you. I appreciate that. We're going to continue. We're going to go through. We're going to get this done. Have to work a little bit later tonight. Sometimes it's the price you pay if you want to stream and for doing some stuff that you love. You have to sacrifice in other ways. My goal is I'm not going to sacrifice my family. I may sacrifice a little sleep in order to get to do some of the things I like to do. Today, we may sacrifice some sleep. So, let's move on. So we have a spare. So now, what do we do with the spare? We need to actually get the value. In order to add to our score, we need to take score plus equals rolls I plus rolls. Wow, Ryan, you cannot spell today. I plus 1. All right. What do we need to do then? If it's no spare, plus rolls I plus 2. So why do we do that? We have our 10. I'm going to take rolls I plus 2. Now, what you're saying is probably valid if you're thinking this or saying it out loud. You know, you can simplify it just by putting 10 because we know it's 10. The reason we have it is we did this little check here. So there's no reason to dereference and get those values again. We already know it's 10. You just need to get the value of the next frame to get it. All right. Otherwise, score plus rolls I plus 1. All right. Is that going to work for us? Let's see what happens. Let's look at our game test here. Ooh, man. How did that happen? Why did that happen? Because we're doing by length. So now it's running across, it's doing this kind of logic for every roll instead of we're now switched to a frame mindset. So we're adding by frames. So there's only 10 frames in the game. So while I is less than 10, and we're going to do I plus 2. Because we want to increment, actually no. Wow. Okay, let's come back here. Is that right? Is that logic right? Yeah, make it prettier. You know what? I'm actually going to I is less than 20. And I'm just going to actually do an I plus plus here because we went through that second frame as well. So now, back to our bulk of our test passing. Oh, yeah. It's rerunning. Just reran everything, and now we have all 3 tests passing. Okay. So, we have a spare. We tested the spare, and it works now. So we can mark that off our list, off our agenda here, off our agenda, and move on to the next one. So hopefully you can kind of see as we go through this how it gets a little bit more complicated as we move through this. But that's the nature of programming. You write the simplest code you can to accomplish your goal. With each new test we write, we change our goal. So moving on to our next test. So our next test is 1 strike. So there are a couple of different, well, let's use our little helper snippet here. Test M. We're going to test one strike. Now, with a strike, there are a couple, it's kind of like a spare, except instead of getting the value of the next roll after the strike, you're going to get the value of the next frame. So the total of the next frame. So if on frame 1 I roll a strike, which means my first roll is a 1 and my second roll is 0, or my first roll is a 10 and my second roll is a 0, then I'm going to get the value of not just the next roll, but the next 2 rolls. Okay? So we're going to roll a strike. So we want to roll a 10. And then we're going to roll 18 more times. And we're going to roll, how do we want to do this? Here we go. Game.roll 2. Game.roll 2. And then we're going to roll 16 more times, zeros. And so 16 more times. And so we still need an assert. So the reason this is still passing, we've not asserted anything yet. So we need to put our assert in here. Assert.r equal. So we have 10. The total of the next frame is going to be 4. So we have 14 plus 4 for that next frame is going to be a total of 18. So we'll have 18 is what our game total should be. Game.total. And we failed. Not surprising. We expect it to fail. Why did it fail is the question. Assert.r equal failed. It expected 18, but actual is 14. So where do we go wrong? So what we're doing here, we checked if we have a spare. Rolls I plus 1 equals 10. Well, if we take that, we rolled a 10, then we rolled a 2. 10 plus 2 is 12, not equal to 10. So it says we don't have a spare. So we need another if statement here. We want to check first if we rolls I is equal to 10, then we have a strike. So when we have a strike, we get score plus equals 10 plus rolls, the next 2 rolls after it. So I plus 1 plus rolls I plus 2. And then we need to increment. All right, so let's test this out here. So it still didn't work, still didn't fail, or still didn't pass. So it says now we have 28. Whoa, what happened there? Let's check this out here. Oh, it's actually going to be in our game. Our test is fine. Our test does what we want it to do. So we have something wrong in our logic. So we have a strike. So we take 10. So I is less than 20. So as we go through this, we're going to say rolls I. So I see what happened here. Actually, I don't see what happened. I don't know why we got 28. So expected was 18, the actual was 28. So we rolled a 10. And it said it was a strike. So then it took 10 plus the next 2 frames, which is 10 plus 2 plus 2, which is 14. Added it to our score, which was 0. I forgot an else statement here. So let's check that out now. Fix that, let it rerun the tests. It may not still be right, but we should get a different value. So what it was doing, it had 2 separate if statements it was doing instead of one logic. So if it was a roll, if it was a strike, it was adding to the score. And then it was going down to this logic and saying if it's a spare, if not, it's not a spare, then go ahead and add the next ones. And then it was moving on. So we want it to actually just run through that logic once. All right, so the assert.r equal failed. Expected 18. Actual is 16. Is 16 right? Let's make sure our logic is correct here. So you get 10 plus the next frame, which is gives you a total of 14, plus the next 2 frames. The next 2 is 4. 4 plus 14 is 18. That should work. Why are we getting 16? Let's look at the logic again here. So we come through first. We say, let's debug it. And that's the best way to do things, is just to run the debugger. I want to debug this method. And actually what I'm going to want to do is I want to debug basically where it does the calculations. All right, so if we step into this here, whoa, your step resulted in an automatic step over. Do you want to? Yeah, we'll go ahead and continue to be notified. Oh, that didn't work. All right, let's change where we put the breakpoint. Let's put the breakpoint in here. Let's calculate method, and let's rerun that. Get rid of that one. We don't need it. Oops, continue on. Let's re-debug this method. All right. So our score is 0. Rolls has a set of 20. 10, 2, 2. Everything else is 0. All right. Let's get started. If rolls is equal to 10. All right. So our score, we expect it to be 14. That's correct. Keep going. Increment I. So let's go back. I is less than 20. So we've got rolls I. So rolls I is equal to 2. I don't get it still. The score here is 16. So what happened here? Our I++ is what happened. So instead of just, because we rolled a strike, we only are going through 1 roll for that frame instead of 2. So what we've got here is our I++ is actually incrementing us 1 extra. So if we have basically either a spare or a non-spare, that's right, because we were skipping two rolls effectively. With a strike, it's only 1 roll. We don't want it to skip the next roll. We want it to just keep moving on. So, know what the problem is here. It's actually a real simple fix. We're going to move this into here. Save. And now we should be green all around. Let our test run. Oh. Still. Index was outside the bounds of the array. So what happened there? Why is the index outside the bounds of the array? Does that tell us in there? Do that. There we go. I don't have to keep going back there. I can just look at it in here. So why is the index outside the bounds of the array? Again, let's debug. Let's find out. Where are we getting off on this? Back here, it's in our calculate method. We're going to stop in here. Don't want to do that. We want to run here. Debug that test. All right. So I is equal to 0. Continue. All right, so we're next to the next iteration. I should equal to 1, all right, which is correct. Our score is 14. So rolls I, is it equal to 10? No. Rolls I, it's 1 plus I plus 1. Is it a spare? Should be 2 plus 2. Nope. Score is equal to 18. Okay, we're going to skip that roll. I is now 3. Is 3 correct? Is that? Let's look at our rolls real quick. 3 is 0. Okay, so yeah, we're where we want to be. Okay, yeah, we should be on 5 next. I is 9. I can look down here in the bottom here. 13, 15, 17, and 19. Okay, so what's happened here? Basically, we're getting, so we're on 19, which is actually the very end of the array. And it's because we skipped that strike. So our for loop is a little off. And it's actually, it's not, I don't think it's a total issue because there's something we forgot. In bowling, the 10th frame can actually have 3 rolls in it. If you get a spare or a strike on your first or second roll, you get to actually bowl 3 times. The fun rules of bowling. So, now, let's stop here. This is actually going to be 21 because we're going to have 21 possible rolls. What we have to make sure of now is that when we do this right, that we make sure we cover all our bases when we actually do our indexing. Let's roll. It's going to recompile. We run it all. 3 tests failed. Why? Index was outside the bounds of the array. I wonder. Let's go back to our simple test here. Our first one, where we roll the gutter game and debug that. All right, so 0. Wow, it's less than 21. It's going to happen. There's where it's going to happen. So when we get past that 20th, so we're going to get up to 20 here. So we're at 20. And we're actually in the 10th frame. So we did the first two. And now it's going to say, okay, I want to check if it's a spare. Because I'm pretty sure that's what's going to happen. So we'll step over that. Nope, not a strike. When it tries to check, it's going to index outside the bounds of the array. So that's what we're getting. So what is the best way to handle that? So let's check our frames. Let's switch this logic up just a little bit. Right. All right, so we're now going to change this. Instead of going by roll logic, we're going to do frame logic. All right, so 10 frames. That's where we need to be. We need to know 10 frames. Okay. Need to know our current roll, but now we're going to do it by frames. So what frame are we on? So one thing we need to keep track of is our frame. So our frame index is equal to 0. All right, so frame if rolls and we're not going to use I anymore because we're in terms of frame. So all right, frame index. If the frame index equals 10, then we're going to do frame index and then frame index. Oh, strikes. What are you doing to me? All right. Sure, I get this logic right. The frame index this is where the tough part comes in. So we're going to keep track of the frames. We need 10 plus whatever we call our strike, what we get from the strike. So it's frame index plus 1, and then frame index plus 2. So the next frame, essentially. All right. Okay. So we've got that. Same thing for the spare. So if it's a spare, we want to get the frame index. So we're using, instead of I, we're using our frame index. And then our, come here. Frame index plus 2. We'll change all these. And we're going to implement a little bit of different logic in here because we're now using a frame index. It's going to change 2. We're now we don't have the I of our for loop is no longer incrementing it. Turn that insert off. Pretty print there. Okay, down here, we're going to fix this here. Other little thing is if you want to move between words effectively or elements, Control plus the arrow keys will skip whole words for you. And it's smart enough to know that it's not just separated by space, but different symbols act differently. All right. Okay. All right. So that we still have some failing tests. Our test 1 strike is still failing. Okay. No problems there. Frame index plus plus because we're moving our frame over. All right. All right, there we go. All right. Now we basically, instead of using the loop to actually keep track of where we are in our frames or rolls, we're actually using the concept of frames, which is what bowling uses for determining either basically your turn. So for each turn you get, you can have up to 2 rolls. If it's a strike, you only get 1. If it's a spare, you get, if you don't get a strike on the first one, you get another chance to knock them down. So now we're moving along in our frames, and that's why this is working now. All right. And as you can see, all our tests are now passing. So some cleanup we can do in here. We can actually create some helper methods here. We can take this and we can extract a method from it. Extract a method. So we're going to take a new method and we're going to call this isStrike. Just to make our code a little bit more readable. Same thing down here. We're going to take this, Control dot, extract a method for it. And this is going to be isSpare. So you notice how smart it was on that last one. It noticed inside the code I was using frame index twice, frame index plus 1 here. But it just put frame index here. So it does use a little bit of intelligence to figure out how you want to break it out. So I'm very happy with some of the stuff they've done. Previously, I've seen it actually take this and make them 2 separate variables in the method. But it didn't here. So, all right. So we're going to clean it up, continue to clean up just a little bit more here. We're going to say, all right, we're going to extract another method here for this. And we're going to call this the strike bonus. I want to take that back. This is going to be the strike bonus because this is what we care about. Extract a method, call this strike bonus. It's trying to be too smart for me here. It extracted too much. I don't want it to do that. I want it to do I just want it to calculate the bonus. I know it's 10 already. That's why I highlighted what I wanted you to do. Come on, Visual Studio, get it together. And then we're going to do a spare bonus here. Just for continuity's sake. I don't want a local. I could do local methods now, but we're not going to do that here. We're going to do spare bonus. It did what I asked it to do last time. All right. So now we have our spare bonus. Wish you would have done that the first time. All right. So as we can see, with every refactoring, it's rerunning the test and making sure what I do doesn't break the game. Take this, we're going to refactor this, make this a little simpler, easier to read. We're going to extract a method here. We're going to, whoa, not what I asked it to do. Or it probably is, I just was not paying attention when I hit enter. Extract method, yeah, that's it. And we're going to call this sum of rolls. Or sum of frame. How about that? Sum of frame makes sense there. Again, naming things is one of the hardest things you're going to do. All right. So, oh, here we go. Let's just fix that back. It did extract a local variable for that, which I don't need. So, refactoring all this kind of stuff makes it quick and easy. I can see what I'm doing here. And now we have test one strike. Our last thing we got to do is we got to test a perfect game. So a perfect game is a 300. Pretty sure it's a 300. But when you go through everything, you basically roll a strike each time. So create a new method here. And we're going to call this test perfect game. All right, so how do we test a perfect game? We're going to roll 10. And remember, the last frame, you actually get 3 chances. You get the chance to do 3 strikes. So we're going to roll 10s, not just 10 times, but 12 times. And then we're going to assert dot r equal expected 300, and our game total is game dot total, and it works. That was our last and final test. Woo. So I do want to look at that, make sure that it used to tell me exactly what the totals were, but we can be confident though, because we know you get to roll 12 total times, get 9 each. The first 9 frames you get to roll 1 strike for each one, and then beyond that you get to roll for the 10th frame, you get to roll 3 times. If you get a strike each time, you get to roll all 3. And you get to roll 3 strikes. And so that gives you your 300 game. That in itself, that is the kata. So the idea that I started with nothing, I started writing tests to the beginning and moved my way through progressively down each test and made basically a game engine that would calculate the score of a bowling game for me. So, what can we do from here? You can add some additional tests. There are some things you can add, some scenarios we may not have accounted for. Maybe we did. But you can certainly add tests. You could add the test spare and final frame. What happens if they actually try to cheat and maybe roll a higher? Instead of rolling 10s, maybe they roll 12 in a frame. So certain tests you can put in, certain bounds to basically make the engine more robust. But the idea is by doing this test over and over again, we're not necessarily worried about the logic we implement here. It's the concept of writing your test, seeing it fail, write the code to make it pass, and if it passes, great. Also make sure that none of the other tests have failed as well. The code that you wrote passes one test, does it pass them all? That is what this is trying to teach you. It's trying to flip your mind a little bit. It's trying to train your mind to, I'm going to write my test first, and I'm only going to write the code that I need to pass this test. So I will get this. I'm going to go ahead. I'm going to put this out on GitHub. I'm going to create a Git repo for it locally, and I'm going to push it up to GitHub later. We're at 2.5 hours, which is an hour and a half past when I wanted to be done. If you followed me, great, thank you. I appreciate what you sticking with us, getting it done. My goal is always to make this an hour, but I ended up talking for 15 minutes, the first 15 minutes. Hopefully you learned something. Leave me comments down below if you're watching this on YouTube, or hit me up on Twitter at RyanO9791, or check out my website, onyxprime.github.io. Hey, why don't we pull that up and show you that? You can see me. You can see my live stream. It's Twitch when I'm going to do it. Here's the link to the YouTube channel down here. If you're unable to watch it or unable to finish it, you can always catch it on YouTube later. What else I want to say? Hit me up on Twitter. You can see up above. So one of the other cool little widgets I gave you a little bit of information on who I am, or how to contact me. My Twitter is over there up in the upper corner at RyanO9791. You reach me on Twitter there. Above me is basically right here, twitch.tv, Developers Garage. If you're watching this on YouTube, you can watch me live, interact, let me know what you think. I appreciate you taking time with me. Next week, the next time we speak, this channel is all about it's not necessarily about open source. It's about improving developers. The best way we can get going and get improving ourselves, as well as the tools we use, is to contribute to the open source community. So like I said, I think earlier, that agenda widget you see down at the bottom corner of your screen is actually something that Mr. Sharp Fritz, Jeffrey Fritz, started writing. I'm guessing it didn't really work out for him, or it wouldn't really fit on his page, because not much has changed since he first started it. But I could kind of see a little benefit for it from my stream. And so what I want to do on my next stream is go in and help make that a little bit more robust, make it easier to edit. Because right now, in order to use it, all those agenda items are hard-coded inside the code. It's running inside a Docker container, which it's great. It's what we want it to do. But I don't want to have to shut down the container, edit that text, restart the container to have it show up. I want to be able to make it run, and I want to be able to edit the agenda item while it's running. I want to be able to edit the title. If I don't want it to say agenda, I want it to say something else. I want to be able to do it on the fly without stopping the container. So what we're going to do is we're going to take its project, we're going to fork it, we're going to pull it down, we're going to make some updates to that specific widget. Then we're going to submit our pull request. So hopefully that Jeff is going to review it. Maybe he'll review it on stream. Check out at Sharp Fritz on Twitch TV to see hopefully that our pull request gets reviewed. But the idea is that we're going out and making the community better, making the tools we use. A lot of tools have been open source because honestly, it's cheaper to source the community than it is to pay for the community, if that makes sense. Because there are a lot of us, we want to make our tools better. We have things that we think are priority, which may not fit into a product backlog for a company. But you know what? We're willing to invest the time to fix it because we see the value in it. And hopefully that's what this stream is going to be about, is building open source projects, working on open source project, making development tools better. Anything that we use in development, making it better. That is what my goal is going to be. I hope you join me. I hope you hang in for the ride. I'm still getting some things going. Hopefully my lighting will be here. My green screen will be a little bit better. I'll continue to look at the stream. If you've got things that you want to see or want to do, hit me up on Twitter. DM me on Twitter. I believe DMs are open. I'll check and make sure. I'm on LinkedIn, Ryan Overton. Ryan P. Overton, I guess is the best way. There is another one out in California, and he is, I believe, in finance. Not me. So, developer, you should be able to see a picture kind of like this. That's how you know it's me. And just get in touch. Also, you can hit me up on, I think, yeah. So use my webpage. I've got a LinkedIn, I've got a GitHub, I've got Twitter, I even got my email out there. Hit me up with an email. Join me. Let's do this together. I think we can have some fun. I think we can learn a lot. We'll get to look at some cool tools. We'll get to make some cool tools. Thank you. I appreciate you taking the time. Hit the follow button on Twitter. I don't know where, not Twitter, but Twitch. Yeah, follow me on Twitter too. Follow me on Twitch. Subscribe over on YouTube. Hit the subscribe button. I think it's down there somewhere. Anyways, hit the subscribe button. You'll get to know whenever I upload any kind of new video. My goal, maybe I don't do everything live. Maybe I actually create some kind of video, which may be some short videos on some little tips and tricks, and we just cut that segment out of the live stream. Maybe that's what we'll do. So, appreciate you sticking with me. I'll continue to improve. Like I said, I will see you next time, next week, if not earlier. Thanks.